Cool. So I'm Tom Denham. I'm a software engineer on Project Calico, and I'm going to talk about Calico today, what it is, why it might be useful for you, and how we've integrated with Rocket, and I'm going to demonstrate that. So what is Calico? So Calico is a really simple way and scalable way of networking containers across multiple hosts and adding additional security at the same time. So before I dive into that, is there anyone here who's tried out Calico with Rocket before? Cool, 2 people. Is there anyone who's tried out Calico without Rocket, with Docker or with Kubernetes or anything? 3 or 4 people. And before tonight, who'd heard of Calico? Maybe half the people. Cool. So Calico is really 2 things. So it's network policy, which is providing this extra security. And that's maybe the more interesting part or the more unique part. It's also multi-host networking, so kind of an opinion about how to do multi-host networking and an implementation of that opinion. So the policy is like providing firewall rules for your containers. So it lets you specify things such as open up port 80 on this container, or allow traffic from these IP ranges. And of course, you don't want to kind of refer to specific containers when you're setting up this policy. So we have this concept of tags. So you can refer to groups of containers. So you can set up rules like on my backend servers, which might be MySQL databases, allow traffic from my app servers on this particular port, incoming traffic, or allow outgoing traffic, but only to my syslog servers or something like that. So you get this very fine-grained policy that lets you specify exactly the traffic that should flow between your different groups of containers. And that policy is implemented at the host level, so on the hosts that the containers are on. So that kind of fine-grained microservice style policy can't be implemented if you're using external hardware firewalls, unless you want to use lots of VLANs and route your traffic in lots of convoluted ways. It works much better if you're enforcing that actually on the hosts where the containers are located. So we use etcd for storing all of this policy information, and the data model in etcd is stable. So if you're writing your own orchestrator, integrating, say, Calico with Rocket, creating a new orchestrator, you can write directly into that etcd data model. But for this demo and for more sort of typical day-to-day use, we have a command line tool as well, Calico Cuttle, and there's some examples of the types of rules that you can set. So the other half of Calico is the networking, so getting traffic from containers on one host to containers on another host. So it's pretty standard nowadays for containers to all have their own IP addresses. We take this a little bit further and give each container its own subnet. So the containers get an IP address on a /32 subnet if you're using an IPv4 network. And so that means that for containers to communicate with other containers, they have to use routing. It's an L3 hop to get to the host and to get to other hosts. But that brings a lot of simplicity, so the traffic can be directly routed between hosts. There's no need to wrap those packets up to encapsulate them in any way. You don't need to add VXLAN headers, anything like that. So that sort of simplicity, that not having any encapsulation, makes it very easy to diagnose a system. You can use all your existing tools, such as ping and traceroute and TCP dump, to see exactly what's going on your network. The packets that your container sends, the IP packets, are the packets that end up on the wire. So it's all very easy and diagnosable. To share this reachability, so which containers live on which hosts, which IP addresses are hosted on each host, we use BGP, Border Gateway Protocol. That's a protocol used by the internet, which is the largest L3 network that I know of. and we know it's fast, scalable, and it allows for easy integration with existing infrastructure. So if you have your own data center and you have a range of public IP addresses, you can peer Calico with your edge router in your data center and assign those public IP addresses directly to containers using Calico. So the traffic's going to be routed from your edge router straight to Calico, no encapsulation, no on and off ramps, all very simple. And no NAT, yeah. So that's kind of what Calico is, brief run through. We recently, coinciding with the Rocket 1.0, integrated with Rocket. A lot of the groundwork for doing that was actually already done because we've been integrated with Kubernetes for a long time. And although Kubernetes used to have a different plugin architecture, this exec plugin, they moved to the CNI plugin architecture, which is what Rocket uses. And we actually integrated with that first before we integrated with Rocket. So when it came to time to integrate with Rocket, my job was very easy because we already had a CNI plugin to do that. The other piece of the puzzle for integrating with Rocket was running the Calico agent that we run on each host using Rocket. So we previously had a Docker image, and we were able to run that Docker image unchanged using Rocket Fly, which there was a talk about at the, I think, previous CoreOS Meetup. So I'm going to demonstrate the integration now. Just like the previous talk, I'm using Vagrant, and I think Vagrant is a great tool for trying out Calico or trying out this sort of thing because it runs on Windows and on Mac and on Linux, and it makes for a very simple setup. So this demo that I'm going to show you is all online. It's on our GitHub. You can check it out. It's as easy as just cloning the project, changing to the right directory, and running Vagrant up. There's no other configuration or anything that you need to run. And there's no magic going on under the covers to kind of set lots of stuff up. So just to show that, this is the Vagrant file that we have, and I'm going to be demoing with two servers, two CoreOS servers. I'm running a recent CoreOS version, an alpha. It has to be greater than 949 because that has Rocket 1.0 in it. And then on each of those two servers, I'm giving them a known IP address, and I'm saying they should be configured with a cloud config file. And then that cloud config file, again, doesn't contain any magic. It's just using the standard CoreOS stuff to set up etcd and starting etcd. And then we have this Calico download service. So this isn't actually running any Calico components. It's just pre-downloading a couple of things just to make the demo run a bit more smoothly. So it's just grabbing the Calico Cuttle helper binary, which I mentioned earlier, and then the Calico CNI plugin, which is what Rocket uses, what Rocket calls out to when it needs to network a container. And then it's just setting up permissions and creating directories. So I've run Vagrant up already. I've got SSH sessions to my two servers that I've got running. There's nothing running on them at the moment. I've run Rocket List, and there's nothing running. So the first step is to run the Calico agent. So I use the Calico Cuttle helper program, and I'll say that I want to use Rocket. So that's just detecting the IP address of this host that I'm running on, and it's using Rocket Run along with the the Rocket Fly stage 1. So we need to use that because Calico, to do the network policy, it's changing IP tables rules on the host, so it needs low-level access to the host. So it's using the stage 1 Fly, the Fly stage 1. And it's running the Calico node, just standard Docker image, and then just passing in a load of environment variables and mounts to set that up. And because Rocket doesn't have built-in support for daemonizing containers, that's all being run under systemd, just creating a transient systemd unit file using systemd run and just naming that Calico node. So I need to run the same thing on the other host. So I now have Calico running on both of my hosts, and I can run the Calico status command to check that it's running okay. So that's just telling me that the container's running, and telling me that it's established a BGP session between the two hosts. So there's no complicated BGP config to set up. That all just works under the covers based on that IP address that's been detected there. If you did want to do more complicated BGP config, that is possible through this Calico command. There's the BGP option in there. So now that I have Calico running on my host, I need to tell Rocket to create containers, or when it creates containers, to network them using Calico. So for that, I need some CNI config, and I'm going to just copy and paste that rather than trying to type it in. So I've started my Calico services. So now I'm going to create these networks. So I'm creating two networks here. Create it on both servers. So this is just standard CNI config that's being placed in the Rocket net.d directory. So the two networks that I'm creating here, I'm calling backend and front end. I'm creating the same config on both servers. I'm setting the type to Calico so that it will call out to Calico. And for the IP address and management, the IPAM, I'm using Calico IPAM. So Calico will choose the IP addresses to use. So that's configured Rocket to use Calico for the networking. So now I can start some services using Calico for the networking. So I'm going to copy and paste again for that. So I should have really used Nginx here for my services. I should have prepared better. But I'm just going to use a BusyBox container running the inbuilt HTTPD daemon there. So I'm using just the standard Docker BusyBox image, running it using Rocket Run. I'm placing it on the front-end network, and HTTPD is configured to just serve up the file system of the container over HTTP. So it's not a very realistic service, but I'm just calling this simple HTTP server my front end. So that's now running again under systemd, and then I'm going to create a similar thing on my second server and call that my backend service. So now I've got two services running on my two different hosts, both just simple HTTP servers, one on the front-end network and one on the back-end network. So the default networking model in Rocket with CNI is that these networks are isolated. So containers that are in the same network can talk to each other, but if you're in a different network, then you can't talk to each other. So I will demonstrate that by running a wget. So actually, first I'll just show that those containers are running. So on my Calico 1, on my first box, I have this, my front end, and it's on the front end network, and it's been given the IP address 192.168.0.0, and my back end has been given the IP address 192.168.0.64. So now if I run another BusyBox container, placing it on the front-end network again, this time I'm just going to run wget to make a request to my service, and the IP address I'm going to request is 0.0, which matches my front end, and I'm just grabbing a file from that server. So if I run that, I should see that I can successfully download a file from my service. Great. And I should be able to run that same command on the other host. and it can also download that file. So this is showing the multi-host networking. So even though my service is running on host 1, I've shared that route using BGP, and I'm able to access that, that from either of my hosts without any port mapping or anything complicated like that. So if I try and access my backend service, which was running on .64, from a front-end network, then this is where the network isolation kicks in, and I should find that my request times out, download timed out. So it's a good job I have the -T1 flag in there to tell it time out after a second. And so that would be the same running on either server. So that's not very useful if my front ends and my back ends can't talk to each other. Luckily, Calico comes to the rescue, and by applying network policy, I can open up, I can put policy in place just to allow my front ends to talk to my back ends only on TCP port 80, not exposing anything more than I need to. So the current network policy that's in place, if I run this Calico Cuttle command to show the policy, I can see that the default is, as I described, it has this isolation. So the inbound rule for the back end is saying that allow only from tag backend. So the backends can only talk to backends, and its outgoing rules, it can talk to anyone. So I want to put some policy in place to open up access. So I'm going to use this rule, which is saying add a backend rule, an inbound rule to allow TCP from my front ends to ports 80. So with that rule in place, I should see that I can now access my, from my network front end, I can now use the IP address of a backend server, which was .64, and I should find that my request now goes through. Ta-da. So I can download the file. So I can do a similar thing for my front ends. I want to be more permissive with my front ends. I want to allow anyone to access my front ends. I don't need to restrict it. They're meant to be exposed to the internet, their front ends. So I can put that rule in place, and now from either of my servers, just directly, without running in a container, I can just access that service running on my front end. So that's all I wanted to show you. So hopefully I've shown you that Calico is a provider of this network policy, as well as doing this inter-host networking. It's very simple to understand, especially for network people. There's no strange new technologies. It's just using standard Linux technology. No encapsulation, makes it very easily diagnosable. It's very easy for people to try out. I'd really encourage everyone to give it a go. I'd love to hear feedback. Just this simple Vagrant setup with a simple cloud config, and it's highly scalable. We regularly test to 100,000 containers over 1,000 hosts. So there are my contact details. There's the GitHub. I've posted these slides already onto the meetup.com page, so you can download them from there. We also have a public Slack where we can give people support. I'll be hanging around afterwards for more questions, and I can take any questions now. Yes?
So if I had something not running in a container, like a F5 or something, how could I set up a rule to something outside the container?
So Chris, take this one.
Yeah, so basically the rules can refer to tags or CIDR blocks.
Oh, okay.
So if you're, so same thing if you wanted to allow from, say, SQL, Q&A testing or SQA testing, and you had that as another pool of addresses somewhere, instead of referring to a tag, you just refer to the address block.
Yeah, is there a big difference if I'm going to deploy the similar configuration using Docker instead of Rocket? So you've shown us a demo on Rocket, and if I'm going to do the same on Docker?
Sure, yeah. So we've been integrated with Docker for a lot longer than Rocket. We actually started with OpenStack and we still do OpenStack. I've been much more involved on the container side. So the first container system we tackled with was Docker. So we work with Docker either by manually adding your containers to the network or through their network plugin architecture. So I could have given a very similar demo using Docker.
An interesting thing is the mechanism is exactly the same, be it OpenStack or Docker or Rocket. All those Calico components, except for the thing that plugs into the orchestrator, is exactly the same. So you could theoretically run multiple environments on the same fabric.
As far as I understand, so it's not a big problem to use the same configuration for OpenStack environment built on Docker containers, for example, and Docker containers built on OpenStack environment, right?
Mm-hmm.
Yep.
People
So
demo that.
similar configuration, similar. Thank you.
Yep.
Policy engine obviously implies you have something managing that policy. I mean, you didn't talk much about that. So what is the policy engine? How is it distributed? How does it work across, say, a cluster of 10,000 for availability and reliability?
Right. So so how it's configured here, I was just showing configuring it initially through Rocket. So Rocket, or in fact the CNI plugin, is setting up that initial configuration to just give those default rules for network isolation. Those rules are stored in an etcd database. So there is a central database cluster, so that gives us the guarantees of it scaling, being fast enough, and persistent and reliable. And then, yeah, does that answer your question? Was there another part?
The key thing, there's no central calculation of policy that's still done on each server. The only thing that's being carried in etcd is that front ends can talk to back ends on port 80. It doesn't have anything specific about what's currently deployed. It just is the intent of the network.
So that container that I showed, that I was spinning up, the Calico node, that's running the agent, and that's listening to etcd for any changes. Anything relevant coming in for that particular node, it'll then render into the actual policy. The item tables rules for that node. Yeah.
So what does this networking look like from the inside of the container? From the container's point of view, is it a /32 route?
Yeah, exactly. So inside the container, it just has that IP address, that /32, and it just has a route that says, yes, send everything out of this interface. It has no way to the outside world except through that interface.
Does it actually have a gateway or is it a point-to-point link? To set it on this device?
Yeah, just send it on the device.
It's a default, dev default route.
One more question.
Yeah, sorry. Yeah.
I was trying to understand why you use BGP and what would be the implications. Do you also use something like the network namespaces, etc., to configure the security policies that you were talking about?
So the first half of that, why do we use BGP? So we think that gives the kind of the best balance for scalability and interoperability. There's no reason why you have to use BGP. You could easily switch it out for some other, like OSPF or something, to exchange those routes. Or you could use static routes. That would be kind of crazy.
And will that work with also the unprivileged containers that you can create? Or does it always have to run as root? Like, I saw that you were running Rocket as root. Is that always the case, or can it also run with like user namespaces and network namespace containers?
That's a good question. So in that container, we're running our BGP daemon, and we're also running our process for doing the network policy. So those two things, I think for both of them, we need to run in the host's network namespace because we're programming routes into the host network, and we're setting these IP tables rules. And I think we need privileged access for that. The sudo for Rocket, I think that's just a property of Rocket more than anything else. But the Rocket Fly container is what's giving us that privileged access. So the equivalent for Docker is we have to run with the / privileged flag.
But the guest containers do not need.
Yeah, so there's nothing special in the guest containers. They're just running as normal containers. So the sudo there that's just how I've got Rocket set up on this machine.
Okay, so you could run it without the sudo, and it should work.
Yeah, absolutely, for the services and the clients that I was running here, the wgets. Yeah.
And will it also work without Rocket or Rocket? Will it also work with things like OpenBG or LXC or some other technology?
Probably. So we support just networking an arbitrary network namespace. So the Calico cuttle command has this container option. So that just lets you add kind of Calico networking to an arbitrary network namespace. So if you set up a network namespace with a local host in, then you can point the path to that namespace, point at using this Calico cuttle command, and then Calico will add a network device in there, set up the routes and stuff for you.
Okay.
I know you've been using this with Kubernetes for a long time.
Yeah.
So everybody in the pod gets the same sort of subnet.
Yeah.
But
Yeah.
as far as I know, we're not using Calico networking. You're still using the Kubernetes networking. For a while there, you were not. You have security policies and you have your networking piece.
Right. Yeah. So we're using both of those with Kubernetes. So yeah, all of the containers in the pod share the same IP address. Kubernetes supports networking plugins, so it'll call out to an external plugin to set up the network interface in that network namespace. So it calls out to us. We've had various levels of support for the policy part through Kubernetes. It's always been possible to use this Calico cuttle command to configure it, but that's kind of out-of-band approach, so not ideal. We'd initially experimented with using annotations on the pod specs for adding in additional policy, but we've been recently demoing using the third-party APIs in Kubernetes and working with Kubernetes and the network SIG group to establish a common format for specifying network policy, and Calico implements that common format of network policy. If that answers your question.
Effectively, every pod is getting its own subnet.
Yes, but it's only a /32 subnet, so it's only one IP address big. Cool. I think that's everyone. So I'm done. Thank you.